Oops, that's 1, 3. Oh, we definitely ran through all of 1, 5. Okay, yeah. Unfortunately, I don't have any of these memorized, so x plus 3y minus z equals 2. X plus y minus z equals 0. And 3x plus 2y minus 3z equals negative 1. Yes? So when you started on this, which one did you try to eliminate first? So looking at this here, again, most of them, they've been kind of nice. We could do x, y, or z. There's not one that's better than the others, because the first equation, x and z, both have 1 in front of them. So they're nice. I can work with those. The middle one, x, y, and z, all have 1 in front of them. So we could use x, y, or z. We'll do z. There's no real reason for picking z. I'm just picking z. And then we'll use the middle one as the eliminator. Again, just picking it. Z equals 2. And our 3x, 3z are our other two. Now, the nice thing is with our eliminator equation and the one on the left, our z's already match up. So x plus y minus z is equal to 0. If the signs are the same, we subtract. If the signs are opposite, we add. So here we're going to subtract all the way through. Because our negative z minus negative z, our second one, that negative negative, is going to make a plus. So negative z plus z is indeed 0. So let's go through the rest. X minus x is 0. 3y minus y is 2y. 2 minus 0 is 2. Okay. Y is by itself. We divide both sides by 2. So y equals 1. And I have a feeling we're going to get y1 on the other one, yes? Mm-hmm. Yep, because we'd multiply through by 3, which is going to get x to cross out also. So, which is probably where you got. And since y is going to eliminate out of, well, x and z are both going to cancel each other out, I'm going to do this again, but with y this time. You can, it's just going to give you on the other one, if we did the cancellation, since x and z both have the same sign, we would multiply by 3. It would cancel out x and y again and give us y by itself. Which does, then we'd have to go back through and try to get x or y's value. So I'm going to get rid of y. Now the left one, I need to multiply it by 3. Because the one on the left, we have 3y. So we're going to get those to match. So if we distribute here, 3 times x is 3x. 3 times y is plus 3y. 3 times negative z is negative 3z. 3 times 0 is 0. 3x plus 3y minus 3z is equal to 0. Now again, the signs are the same. So we would subtract, because 3y minus 3y is 0. X minus 3x is going to be negative 2x. Negative z minus negative z, 3z. Negative and negative make a plus. So negative z plus 3z would be plus 2z. And 2 minus 0 is 2. So we have negative 2x plus 2z equals 2. On the other one, we're going to do essentially the same thing, and just to save on space, instead of multiplying by 3, we're going to multiply by 2 to get it to be 2y. 2 times x is 2x. 2 times y is 2y. 2 times z is 2z, and 0 times 2 is still 0. So you're not negative 2x plus 2y minus 2z is equal to 0. Again, the signs are the same, so we're going to subtract. 3x minus 2x is indeed x. 2y minus 2y is 0, like we wanted. Negative 3z minus negative 2z. Negative, make a plus. Negative z is equal to negative 1. Kind of following so far? Yeah, the fact that y, it ends up with the other two, y would be the only thing left, kind of puts us in a bind. Now here, well, negative 2x plus 2z equals 2. We can do x or z. I'll do x. So for this here, I'm going to take x minus z equals negative 1 and multiply the whole thing by 2, which would give us 2x minus 2z equals negative 2. And I think these two equations look similar, yes? Last but not least, we would add negative 2x plus 2x is 0. 2z plus negative 2z, 0. 2 plus negative 2 is, so this is infinitely many solutions. Infinitely many solutions. Well, that's kind of why we hit that hitch with the x and z eliminating out, because everything that lies on that other line, thank you. So this x minus z equals 1 line, or we could say x is equal to z minus 1, is kind of the solution set. Anything on that line is a solution. And y is 0. So, we can look at others in a little bit. I want to focus on this here, our new no cheat. So, a matrix is a rectangular arrangement of numbers. The dimensions of a matrix with m rows and b columns are m by n. Rows, columns, down, over. So here, we have 2 rows, 3 columns. This is a 2 by 3, and it's stated it here. So the dimensions, rows by columns, down and over. That's how we state the dimensions of a matrix. Questions on this here? Okay. So, a matrix is derived from a system of linear equations, each written in standard form with constant terms on the right and numbers on the left. So variables on one side, numbers on the other. We normally write it x, y, z. It's an augmented matrix of the system. For example, the system below can be represented by an augmented matrix. So, here. And you don't necessarily have to write this down. We'll do some together. If we look at the system, 5x plus 3y minus 2z equals 1. X, y, z equals number. Second one, x, y, z equals number. Third one, x, y, z equals number. Well, if we look at the augmented matrix, we took the coefficients 5, 3, negative 2, 1. 5, 3, negative 2, 1. X, 2y, 3z. So this is 1x. 1, 2, 3, negative 1. 1, 2, 3, negative 1. Last one, 3, negative 4, 1, 10. 3, negative 4, 1, 10. And that's it. So this, I'm not going to make you fill it in, but we get the pattern of how we go from one to the other, yes? All right, let's do one together. So, we want to write an augmented matrix for the system, then state the dimensions. So looking at these two equations, are both of them in the correct order? X, Y, Z, alphabetical. No. The top one, y minus 2x equals 1, yes? Okay. So we need to rewrite it. We need to put what first? X. So it'd be negative 2x. Then what? Plus y equals 1. And the second one is x plus 3y is equal to 12. Okay. Now we want to write it as a matrix, yes? Questions on what we've done? Really all we did was rewrite it so it's xyz, or xy in this case, yes? Numbers going across the top. Our first one would be from x, which is negative 2. Next one would be the number in front of y, and the number in front of y is almost 1. And lastly, we have 1. And then the next equation would be 1, 3, 12. Now, realistically, having it flipped 1, 3, 12, negative 2, 1, 1 is the same thing as just flipping the equation. It's not changing anything. But questions on what we did. Dimensions, rows by column. So how many rows do we have? 2, because going down. So we go down 2. Columns would be 3. So the dimensions of this is a 2 by 3. That's it. That's all it's asking. So we did the augmented matrix. This here is the augmented matrix. This here is the dimensions. Questions on this here? All right. Write the augmented matrix, state the dimensions. Well, first equation, again, we got to flip them. 4x plus 3y equals 13. 2x minus y equals 5. Okay. Let's do our first row. 4 for x, 3 for y, 13. And since it's plus or there's not a sign written in front of it, we're understood to be positive. Our second row, we have 2 for x, negative 1 for y, and 5. And the dimensions for this would be 2 by 3. We go down 2 over 3. So we have 2 going down, 3 going across. 2 by 3. Questions on this here? I was like, why is that so awkwardly spaced? Okay, it's just scrolled up. Okay. So, we have a few things going on with this one here. The first equation, z is on the wrong side of the equation, yes? Because we need x, y, and z on the same side. Okay. So, I'm going to write this to the side because we're going to have to do not so much calculations, but we do need to do some movement. We need to move z from the right side to the left, yes? How can we move it? We can add it to both sides. Because I can come over here and say I'm adding 2z to both sides. Now on the left-hand side, negative 2z plus 2z is 0, telling us that we have 7. Well, we still have 3x. We still have our minus 4y. We just now have plus 2z. Because since none of those are like terms, we can't combine them, but we do get this here. So we don't have that equation anymore. We have 3x minus 4y plus 2z is equal to 7. Okay. We ready to write this in? Yes? Now, writing the first brace, or this first bracket, it takes a little bit of time getting used to, because you could wait and do the first column first, because I could list out the first column, or you could write first one in, either way. I always wait to put the second one after I've listed out the first one, because the first equation will have the exact number of numbers I need, and then I can fill in and mirror. So the first equation, we have 3x minus 4y plus 2z equals 7. So we have 3 from x, negative 4 from y, 2 from z, and 7. So that first equation gives me enough space that all the rest should fill in the same. Let's look at the second one. The number from x would be 9. Our number for y would be 3. Our number from z is not there. So what's the only number that will make something disappear? 0. If a variable is not listed, it's understood to be 0. And then we would have 3. And our last row would be 2, negative 1, 2. So the number of rows by columns would be 3 by 4. And that's it. Questions on this here? We like this so far. Let's look at the next one. XYZ, XYZ, XYZ. Everything's on the right side, yes? Do we have to mess with anything? No. So our first row, 8, negative 3, 1, 5. Our second row would be 2, 1, 4, 2. And lastly, 9, 9, negative 7, negative 3, negative 6. And the dimensions will be 3 by 4. We're ready for the next one. Do we need to see another one of these, or do we feel comfortable with these? We feel good with these, yes? Okay. Many technological or technology tools have matrix features that you can use to solve a system of linear equations. The augmented matrix in example 2, rewritten in reduced row echelon form, is shown below. Observe that the solution to the system x, y, z is negative 1.4, 5.2, 16. So if we look at this here, we have this matrix, yes? Now when we kept writing these in augmented form, we wrote in the form of x, y, z is equal to our number for each equation, yes? So if I look at the first row, let's see what it's saying. It's saying that I have 1x plus 0y plus 0z is equal to negative 1.4, yes? So basically it's saying x right here is equal to negative 1.4, yes? Well, the middle one, well, it's telling us I have 0x, 0y, or 0x, 0z. It's just saying y is equal to and the last one, z is equal to 16. So if we can get it into this reduced row echelon form, where we have that diagonal of ones, it tells me x, y, z, yes? Okay. So that's really what it's telling us, x, y, z. This is also why it's good to have them in that order. X, Y, Z, we don't need them mixed up because the calculator, especially these tools, can't tell that one number is X or one number is Y. It's just a number, and it's just assuming it's going in the same order. So I have this here listed out. I also have included in your note sheet a page that actually has the step-by-step pictures there with it, okay? So if you do not have a graphing calculator, get one now. If you don't have one of those calculators, you need to get one. You need to go grab one of those over there. Clear all that out. Now, I will tell you one thing about both of the calculators that I do use up on the board. If you notice at the bottom, if I do remember to clear it, I'll try to. That space below the screen is a key history. So it'll track everything that I do for this here. All right? So the first thing we need to do for this problem is to rewrite this in our augmented matrix. So if we look at this here, first equation is x, y, z equals number. Second one, x, y, z equals number. Third one, x, y, z equals number. So we're good. Yes, sir. Batteries, or, yep. Just grab a different one at this point. And I'll work on getting those replaced. Yeah, because if they stop working entirely, just let me know. Because if they start saying low battery, we're going to push through until they legit won't work anymore. So, looking at this here, our augmented matrix, the first row, 1, 1, 1, 2. Because 1 for our x, 1 for our y, 1 for our z, 2. Second row would be 2 for x, 3, 2, 3, 1, 3. And the dimensions for this is a 3 by 4. So we feel comfortable with this so far. Yes? Okay. Graphing calculator. So the first thing you're going to do, and I'll do it here in a second, I'm just getting a piece of paper. Second, the blue button, and then we're going to hit matrix. So it's also written in blue, or it's our x to the negative 1. So second matrix. Second matrix. And we get this here. Do we all see the same screen? Okay. So second. And then, so let's quit up. So second, and then hit x to the negative 1. There we go. Okay. So we got there, yes? Okay. Now the first thing we want to do is edit. We want to put the matrix in, our augmented matrix. So we're going to go over to where edit should have a black box with white letters. Are we good? Okay. We have that there, yes? So yours may or may not have like the 3 by 3, 3x3 all the way down. All that means is once we put a matrix in for A, B, C, D, E all the way through, it will give us dimensions. We're going to edit the first one. So you just hit enter. And it should bring the first one up. Yes? First thing it's going to ask is the dimensions. The dimensions of our matrix are what? 3 by 4. After you type each number in, you can use the arrows. I would just hit enter. Because when you hit enter, it will move to the next one. Now yours might not fill the whole, it's going to go outside the screen probably. But we do have 3 by 4. It does look similar to one on our paper, yes? So the one we wrote down on our paper, fill it in. So, and that's part of the reason I got this here. So we have 1, 1, 1, 2. 2, 3, 1, 1, -1. I got off. And go to clear, because that should be 1. Yep. So it's 2, 3, 1, 3, 1, -1, -2, -6. Anybody have any trouble typing it down? I will tell you this now, if you do a negative, we have to use the negative. Because if we do, say, -1 here, syntax error. Because when we do minus plus any of those there, it's looking for something in front of that number to subtract it or add it to. Here, there's nothing, so it's going to throw up an error. Now, normally when you do have an error, we do have 2 options. One of them is quit, and the other go to, or goto, because it looks like goto. It's actually go to. And if you select go to, what it's going to do is it's going to take that cursor to where it perceives the error to be. Go to that error, that spot that's causing an issue. Oh, it's the negative. I did minus instead of a negative. I can fix it. It'll help you get to wherever the issue is a little quicker. Normally, at this point, especially the yellow calculators, if it threw that up, you just hit quit, cleared it out, tried it again. So it's another thing that helps. So we're good with this so far, yes? Second mode, second quit. So second and the button right next to it. Second quit, once you get it all typed in. So this brought us back to the home screen, okay? All right, second matrix. We're going to go second matrix again. Second x -1. You're good? No. Did you get it all typed in? So, let's see. So 1, 1, 2, 2, 3, 1, 3, 1. Okay. -1. -2, -6. Okay, now it's typed in. Second quit. Now second matrix. So second x to the -1. So we're all back to here, yes? Okay, so we put the matrix in, that's good. We're going to go over one. So math. All of these options in this list are different operations we can do or use with matrices. The first one, DET, I don't find to be very helpful. It will tell you the dimensions. Or sorry, DET is determined. It's helpful. Number 3, DIM. I'm going to do this. Don't type this in because I'm just going to show you what this one does. Second matrix A. Hey, the dimensions of matrix A is a 3 by 4. We plugged it in as a 3 by 4. So, second matrix. Now, as it said in this here, and the one that we got the solution for, kind of the example, we need it in reduced row echelon form. RREF. So look through this list for RREF. You can scroll up or down to get there. RREF. We need 2 R's. So we're on B. So you can go up or down to get to it. I would go up. Up's a little quicker. So do y'all have that selected? Hit enter. Once you have it selected, hit enter. And it should say RREF and a little cursor next to it. Yes? So what it's asking, or what we're telling is we want it to change the matrix into the reduced row echelon form. We have to put the matrix. We have to tell it which matrix to apply it to. Okay? So again, we're going to hit second matrix. Now, which one did we put it into? We put it into A, yes? So I need the little box next to A, which is where it starts. We can hit enter. So we should have RREF parentheses matrix A, yes? Hit enter again. We have the diagonal of 1s, yes? So we have -1, 1, 2, yes? So the x value for this problem is -1, the y is 1, and the z is 2. So -1, 1, 2. So our solution for this here is -1, 1, 2. And we'll write them as an ordered triplet, so we can do this here. Questions on this here? How do we feel about these so far? We like these better than what we did yesterday and the day before. So I did include all the steps in this here to do these. Now I will say with these here, if you need or want to borrow a graphing calculator, ask. And up to this point, I've let y'all borrow the ones from the shelf. And normally we haven't had an issue, but last year 3 of them went missing, and I cannot find them. I can't track down who had them. So the ones on this that I have here for the class set are going to stay here. If you need to borrow one, that's fine. I do have other graphing calculators over here. They do the exact same thing. But, you know, the math print for the yellow calculator, you hit a button and it does a fraction written as what looks like a fraction. These don't. That's the only real difference. All right. So I do have I have multiple of these. I just want to make sure those stay here as a class set. All right. Also, these are cheaper. Makes no sense, but I do have these. So if you want to check one out and take one home, just talk to me. I will get those to you so you can take them home and use them. The only thing it won't do is this one here, alpha y equals enter. It won't do that. It'll use the little L. Top number, L, bottom, where you're just going to have to divide. So, we're ready to look at another one of these. We're given a system equation. We need to write it as an augmented matrix first. Well, we have to have it as an augmented matrix to put it into the calculator. It would be the back of that page. Yeah. Because all the steps took up a slide. So our first row would be 2, 3, -1, 15. 3, -9, 9, -12. 4, -3, -1, 19. Aren't lining up. So again, as I said at the year, there's some things that the graphing calculator that will do that are very nice. This is one of them. All right, questions on how we got the augmented matrix? So, clear that out. So we'll go into the graphing calculator. Second matrix. We'll go over to edit. Now, since we're just sticking with one, we can just edit matrix A again. Now it's still A 3 by 4. So you can hit enter, enter, 3, 4. Now our first number is 2, 3, -1, 15, 3, -9, 9, -12, 4, -3, -1, 19. Questions on this so far? Now, the next step is going to be second quit, okay? And there's a reason for it. Because after second quit, we go second matrix over 1 to RREF, yes? I'm going to show you this here. So if I go second matrix math, I find RREF and hit enter. It's trying to put it into the matrix because we could put operations and different things in there for those spots, but that's not what we want. We still need that to be 2. So we have to go second quit to get out of that, out of the edit process. Our next step is second matrix. Over to math. RREF. Okay. Where are we at? Okay. RREF. Yep, enter. Second matrix. Because once we get RREF, did you get everything typed in? Second quit. Second mode. Button next to second. Second matrix. RREF. We won't. So we got that there. Now we need the matrix A. So we are going to go second matrix again. Now that first list lets us recall those matrices. Let us use those with different properties. And since we put it into A, we should have RREFA. Yes? And then we would hit. So the first thing I would do, especially if you don't, the numbers look weird, go back to matrix A, second matrix edit, and just verify that number didn't get transposed or a missing negative or sign. Matrix. Enter. Yep. So just hit enter one more time. So go over to edit. So 2, 3, -1, 15, 3, -9, 9, -12, 4, -3, -1, 19. So we need to go second matrix A. Now hit enter. Yep. I've just done these, used these a while. Okay. So, we liking these so far? All right. So this here was 5, 1, -2. So the solution is 5, 1, -2. Do we need to see another one of these? Okay. Now, before we wrap up, yeah, the rest of them are just doing that there. I'm going to grab my book. Yeah, okay. Now, the one we started the lesson with. Edit. Because it was 13. Okay. So the one that we did at the start, the homework problem number 13, yes? We found out that the solution was infinitely many because we got an equation of 0 = 0, yes? Let's see what the calculator does with it. Second quit. All right. Now at this point we've done a few, yes? I'm going to cursor up and have it highlight RREFA, yes? Enter. So we're still wanting to use RREF, yes? The A matrix is now the one I'm wanting to use, yes? So instead of having to keep recalling it, I can scroll up and pull it back down if we just change it to A. So instead of typing in second matrix over one RREF, second matrix A, I just scrolled up and grabbed the previous RREFA, enter to bring it back down. It's just a shortcut. Now if you notice this here, the first, we don't have a diagonal of ones. Because the first one's 1, 0, negative 1, negative 1. The next one's 0, 1, 0, 1. The last row is what? All zeros, yes? Which is telling us what? All the variables became 0, and it's equal to, so this is all real, or infinitely many solutions. Because if we get that row where it is all zeros, it's infinitely many. Does that make sense? I don't think I'm going to be able to pull this up this easily. I feel I'm going to need to change more than just one number. Yep, because I actually just made a solution. 0, 1, 1. I'm going to have to get one out of the book. 1, 5. Where's that? Ah, second matrix. Edit 3 by 4. 1, 1. Ah, yes. I will get those here in a second. Three. Now we do have decimals, that's not the issue, but if you look at the bottom row, we have 0 for x, 0 for y, 0 for z, 0, 0, 0. So the bottom row is telling us 0 equals 1. That's no solution. Now I think we feel comfortable with solving these. So this is the homework set. We will either A, have time tomorrow, or if we end up not having time tomorrow to work on it in class, we will definitely have time Friday. Most likely you will have a significant amount of the time Friday. So this assignment 3 through 8, 11, 12, 13 through 19 on. So 3 through augmented matrix, yep. And then do the dimensions. 11 and 12, there's 2 parts to 11 and 12. You have to state the error, what they did wrong, and fix it. You have to rewrite it in the correct form. So 11 and 12, you'll end up rewriting that same matrix twice because they're about the same problem. And then 13 through 19, you're doing the system. Okay? So you will have time to work on